So this is a review packet that I gave you in class, and I'm going to go through all the solutions. Our first one is x is greater than 2. So I have an open circle at 2, and I'm shading to the right. Next, we have x is less than or equal to a negative 3. So again, I find negative 3, and I have to fill that in, and I'm shading to the left because it's less than. So open circle for greater than or less than, and filled in circle if it has the bar underneath there, less than or equal to or greater than or equal to. Number 3, we're shading in between. So I have negative 1. Sorry about the dinging. I don't know where my cell phone is, but apparently somebody's trying to text me. So I have negative 1, and then I have a positive 2. So I have an open circle at negative 1 and a closed circle at 2, and I'm shading in between. Number 4 is when I'm shading in 2 different directions. So at negative 3, closed in circle, and it's less than. And then over positive 3, I have an open circle, and then I'm shading to the right because that's greater than. For number 5, I'm solving the inequality and then graphing the solution. So I'm going to need to distribute. So I'm rewriting it as 12x plus 27, and it's greater than 9x plus 45. So I need to get my x's on the same side. I'm going to subtract 9x. So that would give me 3x plus 27 is greater than 45. Subtract 27. And that gives me 3x is greater than 18. And then divide by 3. So we get x is greater than 6. To find your number line, at 6 I'm going to put an open circle because it's just greater than. And then shade to the right. Alright, number 6. Again, I'm solving this, and then we're going to shade our solution. So I need to distribute. So I have negative 25r minus 45 less than or equal to a negative 20r minus 10. I have to do the same thing. I need to get my variables on one side, so I'm going to add 20r. And I'm also going to add 45. So that's gone. So I have negative 5r is less than or equal to 35. Here, to get r by itself, I'm dividing, but this time when I divide, it's a negative number. So because it's a negative number, it reverses my inequality, and I get r is greater than or equal to a negative 7. So again, I find negative 7. This time it's filled in, and I'm shading it to the right. So the first grouping were all linear inequalities. These next 3 are all nonlinear inequalities. So those are the ones we looked at with the square terms and with the rationals or the fractions. So the first one here, it already has 0 on one side of the inequality, and that has to be true before we can solve these. So I'm just going to factor p plus 7 times p plus 6. And we just treat it like equals 0. And then at the end, we'll go back and deal with the inequality part. So this first one, when you set it equal to 0, I get p is negative 7. And the second one, when you set that equal to 0, I get p is equal to a negative 6. So on my number line, I'm going to put negative 7 and negative 6. Neither one of them can be a solution because it was just greater than 0, not greater than or equal to. So I put open circles, and then we just pick values in the intervals. that we can plug in. So I picked -8, -6.5, and then 0. So starting with the -8, if I plug it in, and this is the easiest for me to see what's happening with it, if I plug in -8, I get -1 times -2, so that gives me a positive value. When I plug in -6.5, that gives me a positive 1/2, and then a negative 1/2, so when you multiply those together, you get negative. And when I plug in 0, I get 7 times 6, so I have a positive number. So because these are greater than 0, my solutions are P can be less than -7, or P can be greater than -6. So everything works except for this interval. Number 8 is the same thing as far as finding what zeros and undefined, and then we're going to put them on the number line. So it already has a 0, so that part's good. There's nothing that can make the numerator equal to 0, so we're just looking at the denominator. So what makes -7x minus 5 equal 0? Well, I add 5 to both sides and divide by -7. The only critical value that we have is just -5/7. So on my number line, on the intervals, I'm going to put -1 and then a 0. So if I plug in -1 on the bottom, I get +7 when you multiply those together, -5, so I get a 2 on the bottom. Up top is a negative. So a negative divided by a positive is negative. And then when I plug in 0, I get -7 over -5. And a negative divided by a negative is a positive. So therefore, I wanted to know when it's greater than 0. So my solution is when x is greater than -5/7. And I should have put the open circle because we can never make the denominator equal 0. So it can never be a part of our solution. Number 9, we have more work to do because for 9, we have it not equal to 0. So I have to move that 2 over, and then I also need to get a common denominator so that we can put it together into one fraction. I can't talk about the critical values, what makes it 0 and undefined, until it's one fraction. So I'm going to take that x plus 12 over x plus 1 and then subtract the 2. Now when I subtract that 2 over, I also want to get that common denominator. So if this has an x plus 1 denominator, this has to have an x plus 1 denominator. So multiply that out, and we have x plus 12 minus 2x minus 2 over x plus 1. And 12 minus 2 gives me a 10. X and a -2x is -x over x plus 1. And then I have a 0 on the other side. At this point, now I can finally say, well, what makes it 0 and what makes it undefined? So the top, if it's 10, would make it a 0. And on the bottom, a -1 would make it undefined. So that's what I put on my number line. A -1 and a +10. So pick things in the interval, -2, 0, and 11. If I plug in -2 into this, on the top I'd get a +12, and on the bottom I'd get a -1, so that gives me a negative value. If I plug in 0, I just get 10 over 1, which is positive. And if I plug in 11, I would get -1 over 12, so that's a negative value. So my inequality, I wanted to know when it's less than 0, and it's true in this interval, and then again over here in this interval. So my solutions are x is less than -1 or x is greater than 10. And then number 10 is the last from the inequality section. And again, I have to worry about this because I have a radical. I'm not allowed to have a negative value inside the radical. So I can rewrite this as x cubed minus 2x squared has to be greater than or equal to 0. So factor that, we get x squared and then x minus 2. So x minus 2, that would mean x is equal to 2 when you solve it. Here, I would just get 0, because if x squared equals 0, then x has to be 0. So my solutions are 0 and 2. And I have to make sure that it's bigger, right, than 0. So 0 is okay, right, because this is greater than or equal to. And 2 is okay, because we know that those two values make it equal 0. And then I'm just going to plug in stuff in the intervals and see if there's any other values that work. So I'm going to plug in -1, +1, and 3. When I plug in -1, that part's always going to be a positive, right? When you square anything, it's positive. But when I plug in -1 here, I get a negative value. When I plug in 1 into this, I get a negative value. And if I plug in 3, then that's when I get positive values. So my solutions are x could equal 0, or x has to be greater than or equal to 2. All right, so I will start again with the exponential and logarithmic on my next taping.